I would like to do these three integrals because they are the same type of integrals. Each of them I'm gonna use two methods, so I put them together as to show that the integral techniques for this type of integrals. Okay, number one. Now this one, obviously that I reform the numerator as 1 plus x minus 1, right? Then e to the x and dx 1 plus x squared. Obviously, I want to split this into two integrals. The first one is this over that. This will be 1 over 1 plus x, right? E to the x, and minus dx minus 1 over 1 plus x square e to the x dx. Yeah. Then the first one is e to the x over 1 plus x dx. The second one, I'm prepared for the by parts. So that's e to the x, the derivative of 1 over 1 plus x. That derivative is equal to negative 1 over 1 plus x squared. So I change the negative to positive, right? Then it's equal. This one is equal to e to the x 1 plus x dx. Now that one by parts u dv, right? Therefore is equal to uv, u plus v, this one over this, u times v, minus the v du. V is this. Du is e x dx, right? So this one can cancel with that one. So the result is equal to ex over 1 plus x plus c. Okay, that's the result for my integral. Now, second method is this. Second method, okay, start from here, I'm doing the same thing. Then start from there, that will be equal to 1 plus x e to the x dx minus 1 plus x squared ex dx, right? I start from there. Well, I'm using different method. Well, this one is 1 over 1 plus x times the ex derivative plus 1 over 1 plus x derivative times e to the x, altogether dx, right? E to the x dx is the derivative of x times dx, dx there. 1 over 1 plus x squared is equal to negative 1 over x derivative. So this is the product rule. No? This is the product rule, the derivative of 1 over 1 plus x e to the x derivative, right? Dx. No, sorry. This derivative is equal to this derivative times this plus this derivative, which is this, times that, right? Now, I should put a negative here, because this derivative, this derivative is a negative 1 over 1 plus x squared, so I'll change it plus to negative, and the product rule requires plus in the middle. Yeah, so that one is equal to e to the x 1 plus x plus c. Yeah, okay, that's the second method for this one. Now this one, well, I told you that these integrals are same type, right? Same techniques. I split into two. This is 2x plus 2, right? Yeah, e to the x to 1 plus x plus 1 over 2 1 plus x. Here, e to the x altogether dx. Okay, simply I split in this to 2. 2x plus 3 becomes 2x plus 2 plus 1. Now then, the first one becomes 2 cancel out, 1 cancel out, so it becomes the square x plus 1 ex, right? Dx for the first part. The second part becomes plus integral 2 square root of 1 plus x and ex dx. Yeah. So this one is equal to integral 1 plus x e to the x dx plus this one 1 over 2 square root I can write as the derivative of 1 plus x. This derivative is equal to 1 over 2 square root of 1 plus x dx. So this one is equal to this one. And then I can do by parts for this one. This is equal to square root 1 plus x e to the x dx plus u dv, right? Becomes u times v, u times v. Yes, minus v du. V is this. Du is ex dx, e to the x dx. So that one cancels with this one. The result is equal to e to the x 1 plus x, right, plus c. So this is my integral. Okay. This is the first method, which is similar to my first example. Now, method 2. Method 2 that I start from here. First, I split this into 2. Then this becomes that. I start from here, I'm using different methods. So it is equal to integral square root 1 plus x e to the x dx plus integral 1 plus x e to the x dx, right? The first step is the same. Now from the second step, well, this one is equal to 1 plus x e to the x derivative, right? Yes. Plus, this one is equal to the derivative of 1 plus x square root, right? Derivative is this one times e to the x altogether dx. So obviously this is the product rule, the product of square 1 plus square root 1 plus x times dx. Yeah, that's derivative equal to this derivative times this plus this times that derivative. This derivative times this one plus this derivative times that. That's exactly this. So the result is equal to 1 plus x plus c. Yeah. Same result. Well, I told you that these examples are similar, no? Similar type of integrals. Now, for this one, I first split it into two, right? Let me write this one here. Now, this over that, the first part, x cancel out, right? Which is a log x 2 square root 1 plus x dx. And plus second part, 2 cancel out, x plus 1 plus x cancel out. This is equal to integral cancel out is equal to x 1 plus x, right? dx. Yeah. This over that is this. This over that is this. Okay, and then this one equal to log x 1 plus x dx. Now I write this one as a 1 plus x square root, the derivative of log x. Yeah, that's it. And this one is equal to integral log x to 1 plus x dx. This one I'm using by parts. U dv, right, is equal to uv 1 plus x log x minus v du. Integral v is this. Du is equal to this, right? This is log x to 1 plus x. Yeah. U dv becomes v times du. The derivative of this one is this. So that one cancels this one, you see? This one equal to log x plus c. Now, method 2, start from there. Method 2, start from there, right? This is log x to 1 plus x plus 1 plus x squared altogether, so dx. Okay, start from there. I'm using second method, which is equal to integral how do I treat this? The first one is log x multiplied by 1 plus x squared, 1 square root 1 plus x derivative, right? This derivative is equal to 1 over 2 square root 1 plus x dx, right? Okay, now plus this one is 1 plus x log x derivative. Yeah, altogether dx. This derivative is 1 over 2 square root 1 plus x. This derivative is 1 of x. So this is the product rule. This is the product rule. So this is equal to the derivative of 1 plus square root 1 plus x log x. This derivative times this plus this derivative times this. That's the product rule. That's exactly equal to integral. So this one is equal to 1 plus square root. No. How should I draw? This 1 plus square root 1 plus x log x. So plus c. This is my result. Okay. Now these are three integrals. As I said in the beginning, they can be done by two methods. Their treatment is more or less the same, similar. So this is the reason I put them together. Right. Thank you for your watching.